Hey everybody, we are going to go over chapter 5 in this PowerPoint, and we're going to be talking about concepts, operationalization of your variables, and measurement. And so this chapter is going to be really important for your research paper because it's going to go over how exactly you are going to spell out your variables and how you're going to measure them. So we're going to go over this in a lot of detail in this chapter. Okay, so first, we want to talk about, what are we actually talking about with these things? And so here we're going to really be taking this vague idea. So you guys have already come up with your topic. You've already, gotten it approved. You've done your literature review. And so you have a vague idea about what you want to study. I've made some people's research topics a little more specific than when you originally sent them, but they're still all very vague at this point. And so here's where you're going to really specify what it is we're studying. So really, we begin with conceptualization, which sets up a foundation for our examination of an actual measurement. So for example, if you're saying you want to study the relationship between substance abuse and domestic violence, those are really kind of vague terms, and we are going to want to make them really specific so we know what we're measuring, and that's where these concepts kind of come in. So the central theme of this entire chapter is communication. So we want to communicate exactly how we did our study. So exactly how we collected our data, exactly how we measured our variables, and this really forms the basis for us being able to communicate our findings to other researchers or the public, depending on what we're going to do with our research. So if we say that we investigated the relationship between poverty and crime, we need to explicitly state what type of crime are we looking at. Are we looking at property crime? Are we looking at violent crime? Are we looking at white-collar crime? What do we mean by poverty? How much money do you have to be considered living in poverty? And so we want to make sure that these things are explicitly stated in our research so that we can communicate what our findings are. So this allows other researchers to know exactly what we did, how we did it, and then what's really important with the scientific method, as you all know, is that we need to be able to have replication of our studies. So we can't say that we have discovered the reason behind why people commit crime with our study, and then someone else tries to do the same study we did and they find completely different results. Well, then we didn't really do a good job explaining why crime happens. So replication is important, and other researchers can't replicate your work if they don't know how you measured your variables. So when it comes to conceptions and concepts, we have mental images in our brain when we hear certain things. So we all form our own mental images of concepts based on our personal experiences. So things that we've learned from listening to other people, things that we've observed in our own life, things that we've actually done, touched, been around. So all these things come to our memory or come to the forefront of our brain when we're trying to recall, what does this mean? So, for example, if you ask somebody, what do you hear or what do you think of when you hear the word criminal? So ask yourself, what do you think of when you hear the word criminal? If you were the victim of an assault, then when you hear the word criminal, you may automatically think of the person who assaulted you and others that look like them. If you were the victim of a fraud because you clicked on a link in an email that maybe you shouldn't have clicked on, then you might automatically think of a criminal as someone sitting behind a computer screen in a dark room. Our personal experiences are going to shape what these concepts are in our brain. So in this way, concepts are considered abstract. They could mean a variety of different things, and they're going to probably mean different things to different people. And this is why we have to make sure that we are very specific when we're trying to explain the variables that we're using in our research. So in order to link conceptions, concepts, and measurement all together, there's three kind of classes of measures that scientists use. The first one is going to be a direct observable. So this is the most obvious. The things that we can observe and we can see happen with our own eyes. So things like color, shape, words, saying that the apple is red when the apple is red. If it's a green apple and we're saying it's red, people are going to know that's not correct. So these are things that you can observe with your eyes. Then we have indirect observables, which are a little more complex because you can't observe them directly. You don't see these things happen with your own eyes, but you know that they happen because someone else either recorded them, wrote it down. So for example, indirect observables are things like newspaper stories, court transcripts, criminal history records. And so when we read these records, we read these stories, we can read about past crimes that happened that we weren't able to see with our own eyes. And then finally we have what's known as constructs. And so constructs are more theoretical than observable. These are creations based on things that cannot be observed directly or indirectly. And so for example, let's talk about IQ. So we use IQ scores to talk about people's intelligence. And you can't directly see intelligence. We know it's there. We say that people are smart, people are not smart. And so we know that intelligence is a thing. We are able to test it in different ways. We've created measures in order to kind of get at people's intelligence, but we can't ever directly or even indirectly observe someone's actual intelligence. So instead, we come up with a test that we feel indicates levels of intelligence, and we are able to assign a score to the questions that are asked in that test, and then we tally them all up. We come up with an IQ score. And so the resulting IQ score is a way to talk about someone's intelligence. And the higher their IQ score is, it's assumed that that person has higher level of intelligence. So this is how we measure our concepts. So then we have to come up with conceptualization. And this is the mental process of making these fuzzy and imprecise, these abstract notions more specific and more precise. So, when we talk with our friends, with our family, even if you're listening to the news or something, we are using just everyday communication. And this is made possible through our unspoken agreements about the use of different terms. So this basically allows us to get the general drift of what other people are saying. Even if when I say criminal, we have different images of a criminal, I mean somebody who is committing an illegal act. So even though my idea of a criminal might not be the same as your idea of as a criminal, we get close enough to understand what each other are saying. So although this lets us get through everyday conversation, science really can't operate in this context. We need to be much more specific when we're talking about what we're measuring. For example, if we're, looking at the relationship between drug use and crime, what do you think of when we say drug use? Do you automatically think of people using illegal drugs like heroin? Or do you immediately think of someone using a prescription drug that was actually prescribed to them by a doctor for an illness? Because really, drug use can mean either of those things. So we want to make sure that we're being specific. You might say, oh, well, we're looking at the relationship between drug use and crime, so obviously it's illegal drug use, but, we can't assume that people know that. We're doing research, we're using the scientific method, so we have to be really explicit in what we're saying. So if we want to measure the relationship between drug use and crime, we probably want to mention we're looking at the relationship between illegal drug use and crime. So we want to be specific what we mean by drug use, meaning, illegal, not illegal. Maybe we even want to get even more specific and name specific drugs. We also want to know things like the amount of drug use occurring, how often do people use these things. So there's a whole bunch of stuff that goes into understanding it. But at the very beginning, we want to kind of take this really abstract term of drug use and make it more specific. And then we'll keep going and we'll make it even more and even more and even more specific as we go along. So if the title of your study is examining the relationship between illegal drug use and crime, that's a great start. So the end product of conceptualization is the specific set of indicators of what we have in mind being laid out. So we can divide or subdivide our concepts into dimensions, which are different aspects of a concept. So if we're sticking with our example of drug use, like I said, we can have illegal drugs or legal drugs. And so splitting them up between those two things is kind of step one. And then step two is now we can divide our dimensions into indicators for each of those dimensions, which makes it even more specific. So, for example, if we're talking about the legal drugs, because that's what our study is about, we're going to name each drug that we're looking at. Heroin, cocaine, methamphetamines, and we're going to have a category for each, and those are the indicators. So obviously when we do this, we're just taking that fuzzy concept and we're narrowing it down and narrowing it down. So another example could be if we are talking about the harm caused by crime, we could separate what we mean by that into different dimensions. So we could separate harm into physical harm, economic harm, psychological harm, and those would be the dimensions when we are talking what we mean when we're saying harm. And then if we wanted to go further using our indicators, let's use the physical harm, for example. So for example, we are talking about physical harm. We want our indicators to be things like bruising, cuts, broken bones, because those all indicate this larger concept of physical harm. So again, we want to be really specific in what we're looking at. It leads to, deeper understanding. So our concepts are derived from these mental images that we have that summarize collections of seemingly related observations and experiences. They don't really have real and concrete meanings, and so even though it's okay to use these things in everyday conversation, it's not okay to use these things when we're being scientists and doing research studies. So this is basically saying that the process of regarding as real things that are not, which is a confusing statement, I know, is called reification. So basically this means that we are assuming something is real when it's really an abstract thing. So going back to our example of a criminal, we know a criminal means somebody who is committing illegal acts, but unless we specify exactly what we're talking about, we all have that different image of a criminal, and so this is going to be considered reification. It's really common in everyday life. It's normal. It's totally fine because it helps us understand what each other are saying. It's just not okay when we're doing science. So we want to make sure that we are, being able to take these abstract concepts and specify them down to, the nitty-gritty. So how we do this is going through conceptual order. So this is the design and execution of how we take those concepts and make them specific, concrete things that we can measure. So scientists distinguish three kinds of definitions. There's real definitions, conceptual, and operational definitions. So real definition is the inherently subjective definition that comes from our preconceived notions, our biases, our experiences about a concept. So those real definitions don't work for science. We, however, use conceptual definitions first. So this is a working definition of a concept or term. And so this allows the readers of the study to know exactly what we mean by a concept, and it allows us as researchers to focus what we're trying to do in our study. So for example, if we're looking at socioeconomic status, what that is an index measure, which means that it has a bunch of different components to it. And it's composed of things like occupational status, money that someone has in the bank already, how much property they own, what's their lineage, what's their lifestyle, education level. So all these things together combined can indicate a person's socioeconomic status. So let's say for our specific study, we're talking about socioeconomic status, but we're talking about it in terms of let's say income level and educational attainment, because that's what's important to us for our study. Then we need to say our measure of SES is made up of a combination of income level and educational attainment. So here, we're saying, okay, this is our concept. These are the exact things that make up our concept. That's kind of step one. Step two is coming up with the operational definition. So this is a definition that spells out precisely how the concept will be measured. So at this point, we have conceptualized our concept of socioeconomic status. We've explicitly stated that our concept is going to be made up of income level and educational attainment. And so now we want to specify exactly what we're going to observe, how we're going to observe it, and what interpretations we place on these observations. So let's say that we're talking about the concept or the conceptual definition part of income level. So in order to assess that, we're going to ask our respondents, what was your total household income in the past 12 months? So now we have talked about how exactly we're going to measure income level. Then for educational attainment, we are going to ask, what is the highest level of school you have completed? So that satisfies our how we're going to measure educational attainment. So we're not done yet, because part of operationalizing our variables also includes deciding how we're going to categorize the answers that people give us. So if we're asking about income level and we're asking how much money did you make over the last 12 months, people are going to give us a number, and we're going to have to decide for our research purposes how it's best to categorize this number. So for example, we can have our response categories be something like under 30,000, from 31,000 to 50,000, 51,000 to 70,000, 71,000 to 90,000, if we're going to stick with our intervals of 20,000. So this way it gives us the categories, and so when a respondent answers us, we can circle one of those responses. And we've made this clear to the people reading our research that this is how we divided up our categories. Same thing with education level. So if we want to then to say, educational attainment, and we're asking what's the highest level of school you completed, we could say grade school, middle school education, high school education, some college, bachelor's degree. All those things are different categories of education, and you can do it in different ways also, but these are kind of the more common ways. And so when you get your response, all you have to do is circle one of those, and the people who are reading the study know those were the categories that we included. So we're still not done yet. Finally, we have to specify a way to combine these responses to the two separate questions to create our measure of socioeconomic status. So typically what we do is we assign numbers to each category. So, in our income example, when we had under 30,000, we can assign that a 1. If we have the 31,000 to 50,000, we can assign that a 2. If we have 51,000 to 70,000, we can assign that a 3, and so on and so on. Same thing with the education level. And then we would add those two numbers together. And so let's say that someone answered that they make $65,000. So we would put that in our third category. So we would do the 51,000 to 70,000, and we've assigned that a number 3. And so let's say that they have completed some college. And so if we were doing grade school, middle school, high school, some college, that would be number 4 that we assign to that. And then we would add up the 4 and the 3. And so then people who are reading our study know that if you score higher on this measure of socioeconomic status, that you have a higher level of socioeconomic status. Because let's say that your answer was that you make $20,000 a year and you've only completed some grade school education. So you would get a 1 and a 1, add those together, you get a 2. That's, lower socioeconomic status than someone that has the 7. And again, we're making this very clear in our research paper so that other people know exactly how we measured socioeconomic status. So, we get a lot of, this is social science, a lot of these things are subjective or interpretive, so we might get people disagree with us on how we measured SES. They could say, you should have also included measures of occupation in there. So maybe they don't agree with our operationalization, but it doesn't really matter if they agree or not. They can see exactly how it was measured, they know what was included, and therefore they can interpret our research results because what we are saying when we say socioeconomic status is very clearly specified. So even if they don't like the way that we measured it, which is fine, they know how we measured it, they know what we did, and they can interpret our results. Okay, so this area at the bottom that says progression of measurement steps, this is just trying to show the best way to do it, but it's never this pretty in real life. So we typically have the conceptualization, which is coming up with your research topic. Then we make it a little more specific with our conceptual definition, and we make sure that we have working definition for our concepts and our variables. And then we take it, way further with the operational definition, say exactly what questions we're going to ask, what the responses are how the responses are going to be categorized, and what score we're going to assign to these different categories. And then this lets us make our measurements in the real world. So now we can go ahead and ask our respondents these questions and get actual answers. However, this is not always exactly how things work. A lot of times when we're trying to carry out the study or when we actually sit down to write the questions, we realize, this is not exactly how we wanted to measure things. We might see that we were too vague or maybe even too specific, or maybe that it's impossible to assess this concept in an ethical way in a real world setting. So things like we want to analyze feelings of normlessness amongst people because classic strain theory tells us that when people have this feeling of normlessness, then they're more likely to experience strain and they're more likely to commit crime. But what does normlessness mean to, everyday people? Most people are going to have a different concept, and so it might be hard when we're trying to figure out exactly what we're saying, and we might have to rework it. Your book has a really good example talking about jail stay, and so I encourage you to read that section to see exactly how you might have to re-operationalize and kind of rethink how you're measuring things because this might affect you in your study when you're writing your paper as well. So we already touched on this a little bit, but we have to assign scores to our measures that we have. And this way it allows us to do statistical analyses and allows us to compare and contrast different people's responses. So the measurement is the process of assigning numbers or labels to units of analysis in order to represent conceptual properties. Like I said, it makes us have numbers. So instead of comparing people's incomes by adding up all the different numbers that people said and then trying to divide them, we can put them in a group. We can assign a number to the group, and then we can do our statistical analyses with that small number. It makes things much easier. So kind of everyday examples of measurement would be, or measurement of scoring would be things like having a number or letter grade assigned for your writing assignment. So, getting an 88 on your writing assignment tells you that you got a B+, which means you did some things wrong, but you did most things right. Your book talks about ranking of Supreme Court candidates as qualified, highly qualified, or not qualified. So in order to find who's in each category, you have to assign numbers and say, okay, well, people that scored less than 5 are in the not qualified category. People who scored between 6 and 10 are in the qualified category. People who score over 10 are in the highly qualified category. So, we do this on an everyday basis too. So if you ever were kind of going over your favorite ice cream flavors and you said, from my least favorite to my most favorite ice cream flavor is vanilla, strawberry, chocolate. That is giving your favorites a ranking, and you can assign them from 1, 2, 3. If you have an experience, your book talks about like going on a date, and you can rank your date on your own kind of score. So, people say oftentimes, from 1 to 10, with 1 being the worst, 10 being the best, rank the date that you went on last night. So we do this, part of our everyday conversations in our everyday life. However, many of our criminal justice concepts are not easy to define specifically, and so this sometimes can produce different results amongst different studies. So your book gives a great example talking about when they're studying recidivism. So recidivism means the going back to jail, going back to prison, going back to a program that you were court assigned to after being released. So it's really like reoffending. So most studies, when they look at recidivism, are trying to see what the recidivism rate is. So how many people ended up going back to prison after they were released from prison, for example. I think your book uses a drug rehab program as their example. So, how many people use drugs again after they were released from this drug program? And so we can see that recidivism rates vary significantly depending on how long of a period after release we're looking at. So I want to say in your book it says that, after year 1, 14% of the population reoffended, but at year 3 it was like 47%. And so you can see that if you only have a short amount of time, you're not going to get the full picture. If you give it a little more time, so 2 more years, 3 years, you're going to see a much bigger number. And so it's really important to make sure that you are specific in your research, because if somebody was reading your study and you were like, oh, this drug rehab facility only has a 14% reoffending rate after they complete it, you might think that program is really great, and you're going to invest a lot of time and money, and you want to open it in other areas because it was doing really well. And maybe that wasn't the case, because if you look at the 3-year numbers, almost 50% of the people that graduated from that drug rehab program ended up reoffending. So this is why it's important to be specific in what you're measuring, so people can see, well, this person only included 1 year, and I would be more interested in knowing how many people reoffended after 3 years instead. So, making sure that you're specific. Sometimes reporting numbers for more than 1 year is common. In the recidivism research, for example, people tend to always use a 3 to 5 year period because they know that these numbers are going to be more accurate versus 1-year numbers. So, being specific helps other researchers understand, okay, this is what I should do too. All right, so some of the things that we need to have when we are making our variables is the qualities of being exhaustive and exclusive. So the attributes, which are characteristic, which is the characteristic or quality of something that composes a variable, should be exhaustive. So what that means is that we want to be able to classify every observation in terms of one of the attributes that we assigned to our variable. So if we're trying, for example, to study criminal sentences, and so our variable is criminal sentence. So we then need to, remember, have indicators for what we mean by criminal sentence. And so let's say that we have only included prison and fine as our answers to criminal sentence. Well, that's going to leave out a whole bunch of people because not everybody who gets sentenced gets either prison or a fine. They could also get probation. They could also have their sentence delayed. So there's a lot of different variations that go in there, and it's our job as researchers to make sure that we account for every possible answer. And so this is why sometimes using other is a helpful tool, because if you know that there's other responses out there, but it doesn't make sense to go through each and every one, maybe there's just way too many, or you're only really trying to measure the big ones, then you can have this other category so that people who don't fall into those more specific categories have somewhere to answer. Have you ever taken a survey before when one of the questions didn't necessarily apply to you and you had to give an answer? So you just kind of made up a number or guessed. We don't want that to happen because that's just giving false data. So having these other categories sometimes helps with that. Excuse me. So the second measurement requirement is going to be mutual exclusiveness. So this means that we have to be able to classify every observation we have in terms of only one attribute. So the attributes composing a variable can't overlap. This is what we mean by mutually exclusive. They can't overlap. So for example, if we're looking at criminal sentences and we're having, fines, prison, probation, other, what happens to the people that have both prison and a fine? So they were sentenced to both. We need to classify people so that, or we need to classify our measurement, our variable, our attributes to make sure that this person is not counted twice. Because where do we put them? Do we put them in the prison category or do we put them in the fine category? We don't want to count them twice because then it's going to look like we have more measures than actual people in our study, and that's not accurate. So for this example, it would be best to include another category. So we could have prison only, fine only, both prison and fine. And so this way, that person has somewhere to go. And that's just showing another level of our attribute, which again helps with the exhaustiveness too. So every good variable is going to have these two qualities at the bare minimum. And that brings us into our levels of measurement. So it's important to know what our level of measurement is, because this is going to tell us what sorts of information we can gain from the scores we assign to the values of a variable. So remember I said we assign numbers like 1, 2, 3, 4 so that we can do statistical analyses. So those things are like giving us the average, telling us if there's more in one category than another. And so some of our statistical analyses can only be done on variables that are measured at a specific level. So first of all, we need to go over what the levels are. So the first one is nominal measurement. And so nominal measures only have the characteristics of being exhaustive and mutually exclusive. So as long as they satisfy those two categories, they are and only those two categories, they're considered nominal. So the attributes can only tell us which category our respondent falls in. It can't tell us anything about their rank order or anything like that. So examples are things like race, gender, state of residence. So, if you had a group of individuals standing in a room and you asked them what state they lived in, and so they told you the state and you put them in that group. And so let's say they said Texas, Florida, Vermont, New Jersey. And so now they're all separated into different categories. So they can't be in two because they're only from one state, unless you couldn't be born in two states unless you're literally born on the state line. And that would be, pick one at that point. So you are only going to be in one group. And so you know that you share one thing in common with everyone in that group, which is you're born in this state or you live in this state. And so it's really all what you can do. Because does it matter if you put Florida before Texas or Texas before Vermont? Doesn't matter. That doesn't tell us anything, doesn't give us any useful information. All we want to know is what state are you from? Go stand in the group of other people that come from your state. Okay. And then we have ordinal levels of measurement. And so these satisfy the requirements of being mutually exclusive and exhaustive, but also they're able to tell us if the different attributes represent relatively more or less of a variable. So let's take education as an example. So when we are measuring education like we were before, we can have different categories. So we can have grade school education, middle school education, high school education, let's say some college, and then a college degree. So we know that if we're talking about someone who has a college degree, that they have had more education than someone who just has a grade school level education. So this makes sense in a logical order. If we were to kind of mix things up and we took some college and put it in between middle school and high school, then now our ranking doesn't make any sense because you have to go through high school before you can get to college. So this way, you're messing up the rank order of things and it's not going to make logical sense at that point. So it doesn't matter, if you assign them different numbers, you could assign grade school education as being a 2, and you can assign middle school education as being an 8. And as long as you made sure that, the numbers went up as you went over the list, they don't really matter in other terms. It doesn't mean that you've had twice as much education as someone in grade school. We can't tell those things, but we can tell you're mutually exclusive because you only fall in one category. It's exhaustive because we can include as many levels of education as we wish for our study, and we can always put in another category also. And also we can rank them in order as to less education to more education. So that's about as far as you can go with ordinal measurements. Then we have interval measures, where there's an actual meaningful distance between these different attributes that we have. And temperature, I know, is not necessarily a criminal justice measurement, but this, is one of the best ways to explain what interval level measures mean. So let's say that we're discussing temperature in Fahrenheit, so in degrees Fahrenheit, and we say that 80 degrees is 10 more degrees than 70 degrees. And we could all agree that that's correct. And we can say that because there's a meaningful distance between 70 degrees and 80 degrees. There's 10 degrees of a difference there, and so we can say that. We can also say that there is the same difference between 70 and 80 degrees as there is between 40 and 50 degrees, because both of them are going to have 10 degrees difference between them. And so we can say things like that because there's a meaningful distance between the two. However, we cannot say that 80 degrees is twice as hot as 40 degrees. And this is where it gets a little confusing, but the reason why we can't say that is because the 0 on the Fahrenheit scale is kind of arbitrarily placed. So, 32 degrees means that things start to freeze. So freezing temperature is 32 degrees. Freezing temperature does not mean that there's an absence of heat. And you can go all the way down to 0 degrees. So luckily we don't live in an area where we typically see 0 degree temperatures. My sister lives in Colorado and she just saw -3 temperatures the other day. But again, that 0 doesn't mean complete absence of heat. So because of this, the 0 is considered an arbitrary point, and so we can't say that one is twice as hot as another one. We can't give you the ratio. We can only tell you what the difference is between the two numbers. So, 40 degrees is 40 degrees warmer than 0 degrees. But we can't say that it's 40 times higher, because that's a ratio measure. And just so you know, the only temperature scale that has a true 0 is the Kelvin scale. And so on the Kelvin temperature scale, 0 degrees means no heat, the complete absence of heat. But that's not true for Fahrenheit and Celsius. Okay, and then our final level of measurement is going to be ratio measures. And here we have a true 0 point. So this means that the 0 on the scale is meaningful. So we can take age, for example. If you say that someone is 0 years old, it means that they have not been alive for a whole year yet. It doesn't mean that they're not alive, because you can be 1 month, 2 months, 3 months, but we're talking about years. And so 0 years means that you have not even been alive for a whole year. On this scale, we can say that, if you are 10 years old, you've been alive for 10 whole years. And you can say that 20 is double the age of 10, because you've been alive for 10 whole years, then you've been alive for another 10 whole years to get to 20. So you can say that, 20 is double the age of 10, and that's a ratio, and it's because it has a true 0 point. You can do the same thing with number of prior arrests. If you've been arrested 0 times, then that 0 is meaningful. It means that you have 0 arrests, no arrests. You have 1, that means you've been arrested once. You have 2, that means you've been arrested twice. And you can say that 2 is double the amount of 1, because again, the 0 is meaningful. So sentence length, income, those things are all ratio level measures. So different variables are going to be measured in different ways. And so some of them are just inherent. Like you can only do gender as a nominal variable. You cannot do it in any other way. But sometimes you can measure something as a ratio measure and, simplify it to a nominal measure. So we always kind of want to aim for the most expressive ratio or level of measurement, which is ratio. And the reason is because if we're comparing two people in terms of a ratio variable, we can tell whether they are different or the same, whether one is more or less than the other, how much of a difference there is, and what the ratio of one to another is. So if we're talking about nominal level measures, we can only say whether they're different or the same. If we're talking about ordinal level measures, we can tell if they're different or the same and whether one is more than the other. When it's interval level measures, we can tell whether they're different or the same, whether one is more than the other, and also how much they differ by. And then, of course, ratio level measure, you can do all four of those things. So all those three things plus you can say what the ratio of one is to another. And so this is what they mean when they're talking about implications of level of measurement. Ratio level is considered the highest. So you can do all four of them. Nominal is considered the lowest, so you can only do the one which is say, are they different? You can convert a a higher level measurement to a lower one. So like I said before, you can take a ratio level measure and break it and kind of simplify it into just knowing, are they different from another? But you can't take a lower level measurement and make it into a higher one. So, different statistical techniques are going to require that variables meet a certain minimum level of measurement. For example, can you average gender? No, not really. So let's say that you want to you're just looking for simplicity purposes, we're going to say that gender is male or female. Obviously, there's other categories that you can include in that, but we're just going to stick with male and female for our example. Can you average that? No, it wouldn't make any sense mathematically or logically to take an average of that variable. What you can do is tell us the mode, which is the most common. So you could say, in our study, the mode of gender was this, which meant that most of our study was comprised of females, or most of our study was comprised of males. That's really as far as you can go with that. Let's see. So you can take the mean of ratio level data. You can do it for interval level data. You can technically do it for ordinal level data, but it's usually not meaningful since there's no meaningful distance between the measures. Like I said in my example of education, you can assign like a 2, a 4, a 6, and 8 to the different categories. And so or you could do a 2, a 7, a 10, as long as one means more than the other, one is higher than the other, then you know where they rank. But those numbers are meaningless. So although you could do an average, it really wouldn't make sense. So it's more accurate to use the median, which is the middle number. So when you are determining, you're operationalizing your variables, the analytic uses that you plan for a given variable should determine the level of measurement you want to use. And you want to make sure that when you're operationalizing your variable, that you are hitting that level of measurement that's required for your statistics. Okay, so measurements can be made with varying degrees of precision. As a general rule, precise measurements are going to be superior to imprecise ones, but that's not always necessary depending on what you're studying and how you're studying it. So let's say, for example, we're trying to ask a question about age. And so when assessing age, is it enough to ask if a person falls within a certain age range? So let's say that we're going to classify everyone between the age of 10 and 19 as a teenager. We're going to classify everyone from 20 to 29 as a young adult. And so we can have, that group. Or is it better for our study to have a more precise measurement of age where we are doing actual, 14, 15, 16, 17? Typically it's not necessary to be that precise when we're talking about age. It's usually okay to lump people together, at least into you can do wider groups or smaller groups depending on what you're looking at. And so that's typically all that's necessary. It doesn't make sense really to go any farther than that. So a lot of times people confuse precision with accuracy, but sometimes being less precise is actually more realistic to what we see in the real world. So that's something to keep in mind when you're creating your categories as how you're going to categorize answers. All right, so now we're going to get into two critical considerations known as reliability and validity of our measures. So reliability is basically talking about consistency. So whether a particular measurement technique will yield the same result each time. We want our measures to be reliable, meaning that we aren't measuring one thing one time and something else another time and something else another time, that we're consistently measuring the same thing. So this is oftentimes a problem with indicators that we use in criminal justice research, because sometimes things aren't reported the same way every time. So let's use police records as an example. If someone is, I think your book uses an example of robbery or burglary, and so when they had, people who were, or different police officers, street officers, who were kind of the first responders, patrol officers, when they were the ones that were recording burglary data, they typically were not using the strict definition for burglary. And so sometimes they included crimes that did not fall under that really strict definition of what a burglary is. And then when they switched from having patrol officers investigate burglaries to having detectives investigate burglaries, the data looked like there was a significant drop in burglaries, but really the detectives were a lot more strict and only including events that fell under that strict category for burglary. So then, we get an issue with reliability because things weren't being measured the same way every single time. So reliability is often a concern when we have a single observer, because we can't really be sure how much of what's reported represents true variation and how much of what's reported represents the researcher's own unique perceptions, and there's really no way to tell, although we do have some techniques. But we also have an issue with multiple observers, because different interviewers sometimes get different answers from respondents due to their own attitudes, their own demeanor. So, somebody who is asking face-to-face questions about sexual assault, and they kind of come off, naturally just as cold and uncaring, then maybe the person who's responding isn't going to give them a lot of detail, versus a person who is naturally comes off as warm and caring and more bubbly. They might get a lot more detail from the victim of sexual assault than the other person. And it's not that they're consciously trying to make these differences. It's just kind of something that happens naturally. So we want to make sure that we are able to test this. And so some ways that we do this, some ways to deal with problems with reliability, are things like the test-retest method. So this is where we take the same measurement more than once from the same person, and unless we have reason to believe that there should be a difference, we should expect the same response both times. So if the answers vary, then the measurement method is not considered reliable. Sometimes we see different answers because of things like faulty memory, so it's better to do this test and then retest within a short period of time, 6 months, a year at the most, and that way people still have the information fresh in their mind. It's not that they're trying to lie, it's just sometimes they forget. Another way to deal with reliability is called inter-rater reliability, and you can do this two different ways. One is to compare measurements from different raters. So if you have multiple researchers, let's say they're coding data from the census, and you have them code the same data in the same way and then compare their information, and this way you can make sure that any mistakes are caught. So if they should all be the same, and if for some reason the numbers aren't the same, then you can say, wait, what's going on here? Let's go back to the actual data and see who's right and who's wrong. Sometimes people just make a mistake when they're entering in numbers. Another way to do it would be to verify initial measurements. So your book talks about how in one study they had different responders or different researchers going out and asking questions, and then once they had all the data together, they took like a subsample of that larger sample and called them and just asked them a couple of different questions that were on in the survey, and just to verify their answers. So that would be another way to do it. And obviously you want them to have the same answers. The third way to deal with reliability is called the split half method. So typically when we're making our surveys and things like that, we have more than one measure of any concept. So for example, if we're asking about people's self-control, we have multiple questions that get at that concept of self-control. So the idea here is that let's say you're asking about self-control and you have 10 different questions that ask all about self-control. You should be able to split this into 2 measures of 5. And if you were asking it to the same respondent, you would expect similar scores because they're all trying to ask the question, how much self-control do you have? So you should expect a similar outcome. Okay, so reliability, all about consistency and responses. Validity talks about the extent to which an empirical measure actually reflects the meaning of the concept that we're considering. So we want to know, are our measures actually measuring what we think they are? Does our operational definition accurately reflect the concept we're interested in? And this is a lot harder to get at than reliability because the concepts are abstract. We're trying to make sure that we're getting at this concept, but we are kind of creating our own ways of measuring it. So we're asking basically, is our measure of crime valid? Are we actually measuring crime by asking these questions? So we have a couple of different ways, I think 5 different ways in particular, of dealing with validity issues. So the first one is known as face validity. And this is saying on its face, like if you asked random people on the street, do you think this question measures this? Would they say yes or no? So for example, if we want to know about police satisfaction or satisfaction with police services, does counting the number of citizen complaints regarding police services measure the satisfaction with police services? Well, there's definitely other ways that you can measure this, but we are getting at citizen satisfaction with police services when we're looking at official complaints. So yes, it does. On the other hand, if we were trying to measure satisfaction of police services by asking police officers how much time they spend watching videos of police chases on the internet, that does not match with what we're trying to get at. Like, how does that answer our question of what are citizens satisfied with police services? So, you want to make sure that they jibe, that they go together. When it comes to criterion-related validity, this is comparing a measure to some external criterion. So a lot of times in our research, we will validate our measures of a topic or a concept by showing that it predicts scores on another measure that is generally accepted as valid. So your book has a really good example. Researchers wanted to understand if they were having a valid measure of alcohol-related auto accidents. And so a lot of times this is done by breath alcohol blood content, but not every single person gives alcohol blood content, so they wanted to get a more wider measure. And so instead of using that, They measured vehicle accidents that occurred between, or single vehicle accidents that occurred between midnight and 3 a.m. And so they then compared their numbers to blood alcohol test results from two specific places, and they found that their numbers were similar. So this way they said, okay, well, our measure of single vehicle car accidents between 12 a.m. and 3 a.m. is a valid measure of drunk driving accidents, because we compared it to this other measure which uses the blood alcohol content, and it's similar, so we can confidently say that yes, that's what we're getting at. So then we have construct validity. So this is if we are measuring one variable, then we know how we expect it to relate to another variable, and so we want to make sure that it is related in the expected direction. So for example, if we are measuring fear of crime, then we would assume that people who have greater fear of crime are less likely to leave their house at night, because if you're scared of crime, then you don't want to go out in the middle of the night where crime is more likely to happen. So therefore, higher fear of crime should equal less going out at night. So if you find that people who answer yes, they're scared of crime, and also no, we don't go out at night, then your measure is valid. It has that construct validity. When it comes to content validity, it's important to make sure that our measure covers all meanings included within a concept, unless we're specifically saying that we're only interested in a small part of the meaning. So for example, let's say that we're studying fear of crime again, and we ask the question, how safe do you feel walking alone at night? So unless we're only trying to study street crimes, this is not going to be a good measure of all crimes. We're going to have to ask other questions too, because how does how safe you feel walking alone at night relate to cybercrime? You don't have to be walking alone late at night to be a victim of cybercrime. Your book has a good one. If the crime of airplane hijackers, what does walking alone in the neighborhood have to do with that? So unless we're only measuring street crimes, we'd have to ask more questions to get at fear of crime. So when it comes to multiple measures, another approach to validation of an individual measure is to compare it with alternative measures of the same concept. So for example, if we are asking a self-report survey and we're asking people to report how many times they've been arrested, we can then take their self-report, and we can compare it to actual arrest records that we have to see, how accurate they are. And that way we can see if our questions are overlapping with that official data. And if it is, then we can say that that's a reliable and valid measure. Hope that makes sense. Okay, so oftentimes in CRIM research, what we do is we combine individual measures to create a composite measure. And so this is a single measure that captures the variable of interest. So for example, when I'm saying crime, what type of crime are we talking about? Are we talking about violent crime? Are we talking about property crime? Are we talking about all crimes? Because then we have to include questions about all crimes, and then we want to kind of put it all together into this composite measure of crime. So we want to, let's make it a little bit easier, because that's could be a lot of different questions. So for example, let's say we're talking about violent crime in particular. So violent crime consists of murder, rape, robbery, and assault. In our study, that's the definition of violent crime. It's one of those four, or multiple. So let's say that We ask, have you ever been a victim of murder? Or, sorry, that's dumb. Have you ever been a victim of assault? Have you ever been a victim of robbery? Have you ever been a victim of rape? And so then we would combine those answers into one. You can always look at official data and see, have they ever been victims of those crimes, and have they been victim of murder? And then that way we can add all those up together and say, this is this composite measure of violent crime, because it includes all these different aspects of violent crime. So the reason that we do this is because, number one, the researcher is often unable to develop single indicators of complex concepts. So like I said, violent crime is more than just one thing. It has multiple aspects to it. We want to include all those aspects. This is especially true when we're talking about attitudes and opinions of things. So the fear of crime measure, only asking about walking alone at night. If we're trying to measure different types of crime, we're going to have to ask, how about, are you, do you fear going on the computer? Like things like that would get at different crimes as well. Another reason that we use these is that we may wish to use a ordinal measure, arranging cases in ordinal categories from very low to very high on a variable. And we can't do this if we only have one measure, especially if that's a nominal measure. So sometimes we need to combine things so we have an actual score, 1, 2, 3, 4, 5. When meaning, 5 meaning that we have more of something than if we had a score of 1. And then finally, indexes and scales are efficient devices for data analysis. So indexes and scales are two different types of composite measures. So this gives, considering several data items gives us a more comprehensive and more accurate indication of a given variable. And it allows several indicators to be summarized in a single numerical score. So again, if we're talking about violent crime, we can't just ask about murder. There's other types of violent crime out there, and so this allows us to be much more accurate and much more inclusive of all the different types of violent crime that's out there. Okay, so finally, we have what's known as typologies, which is also sometimes called a taxonomy, and these are produced by the intersection of two or more variables to create a set of categories or types. So, for example, if we're talking about substance abuse, we can have different categories of a non-user, alcohol only, marijuana only, cocaine only. We can have combination. And so this is an efficient way for us to measure complex and detailed variables. So they allow us to combine scores on multiple measures or combine scores on two measures, and that way it allows us to get kind of a wider, broader picture. So for example, let's say we want to measure social disorder, and we want to include several different variables because social disorder can mean different things. So in order to talk about social disorder, we're going to include groups of loiterers, drug use and sales, vandalism, gang activity, public drinking, street harassment, graffiti. And so we're going to ask respondents to rank each of these variables, and let's say that we're going to ask them, do you think that drug use and sales is a problem in your area? And they would say no, which is rank. We're going to give a number as a 0. We're going to say, they can say it's some problem, that will give us a 1, or a big problem, we're going to score that as a 2. Then we would add up each of the responses for each of the variables. So, we're talking about each one, they have a numerical score, we add them all up, and then that is the index score for the respondent on social disorder. So if they answered 2 to most or every single question, they're going to have a really high score on that, and we're going to say that, okay, this person believes that there's a lot of social disorder in their neighborhood. So this allows us to see how the respondent's perception of social disorder is related to their fear of crime, if that's what we're looking at. A composite measure is typically a more valid measure of disorder than just a single question, because if we just were asking, first of all, if we were asking, do you think there's social disorder, that is going to be a really abstract concept. What is social disorder? What do you mean by that? People are going to have different ideas, their different mental images, and so using just that term of social disorder is not going to give us any accurate information. So that's why we have to break it down into several variables. And if we only included groups of loiters and vandalism, then we're missing a lot of the picture here. There's other things that people could assume, like public drinking, gang activities, street harassment. Those all will also indicate social disorder. So only including one or two is not going to give us a really valid measure of social disorder. Computing and averaging across all items in a category creates more variation in the index than we could obtain with a single item. So we want that variation because we want to be as exhaustive as possible in our measures, and this allows us to get at that. And two indexes are more parsimonious than several various individual variables. So if you have two indexes of something, then typically you're going to see a lot more agreement on those variables than if you were asking individual questions and not adding them up together. So a lot of people might have a problem with public drinking, but so you might see really high scores on that one in particular, but people are going to vary in the groups of loiterers and how they view that. So including this and putting it together in a typology or an index allows us to get a more clear picture as to what social disorder actually is. All right, so I hope that helps, and if you guys have any questions, as always, feel free to ask me. Thank you.